Hi everyone. Today we're going to work on 7.3 notes, which is about tangent lines. So first of all, we know what is a tangent line. We know it's a line that touches the circle only at one point. Now, if you have the tangent line and you also draw the radius of the circle to this point, you will see that there is an angle here, which is equal to 90 degrees. These two lines are perpendicular. So you can say if a line is tangent to a circle, then it makes a 90-degree angle with the radius. The other way of this statement is also true. That means if a line is perpendicular to the radius at the point on the circle, then the line is tangent. So that means if you see there is a line here and it's perpendicular to a radius, that means it's touching the circle at this point and it's tangent line. Okay, so we're going to use the same idea to solve some of these problems. So as you see here, we have a tangent line. This is our tangent line because it's crossing the circle at only one point. And here is our radius of the circle. So we just learned if you have tangent line and the radius meeting at one point, they're going to create a 90-degree angle here. So as you see, there's another line going from P to S. So there is a right triangle here. Now on this right triangle, we have two sides given, and we're interested to find the third side. So you know that you can use the Pythagorean theorem. I'm going to write a squared plus b squared equal to c squared. We know c squared, or c basically, is the hypotenuse. What is the hypotenuse on this shape? It's the side which is opposite 90. So this side is hypotenuse, which would be called as c. And the other two sides, A and B, are the ones that are touching the 90-degree angle. So this could be A, this could be B, or you could call them the other way. It doesn't really matter. Anyway, so I'm going to solve A squared plus B is 12. 12 squared is equal to C, or hypotenuse, is 13 squared. So I have A squared plus 144 equal to 169. Now I subtract 144 from both sides. These two cancel. Then A squared will be equal to 169 minus 144 is 25. And A will be square root of 25, which is 5. So that's our answer. That's the other side of this triangle. Okay, let's work on this example. Again, we see a tangent line. This AC is the tangent line, and here we have the radius, and they make a 90-degree angle with each other, the radius and the tangent line. So again, we have a right triangle, and now we're going to use the Pythagorean theorem. The two sides that are touching the 90 degrees, they're A and B. Hypotenuse is always the side which is opposite 90, and that's going to be on the right side of the equation. So I'm going to write 7 squared plus 24 squared equal to c squared. So if you add these two, that's going to be 625 equal to c squared, and c will be square root of 625, which is 25. So that's the answer. Okay, now let's work on the next problem. The next problems basically are about this new theorem. New theorem says if you have a point outside of the circle, let's call that A, and then you draw two tangent lines to this circle from this point. So that means I'm going to draw one line this way, it's going to touch the circle at this point, and another one here. So they're both tangent lines, and they're touching the circle because they're tangent, of course. So the theorem says if two segments are tangent to a circle from the same external point, then those two segments are congruent. So this line is going to be equal to this line. Let me call this point as B and this point as C. So these two are equal to each other. I can say AB is equal to AC. Now we're going to use the same idea to solve some problems here. As you see, we have one point outside of the circle, and then we have two tangent lines. They're coming from the same point. So that means this line is equal to this line. So the distance from here to this point is equal to distance from here to this point. And they're given. They're equal to each other. So I'm going to write 3x plus 2 equal to x plus 8. Now, I'm going to subtract 2 from both sides. 3x will be equal to x plus 8 minus 2 is 6. And I move the x to the other side. 2x will be equal to 6. And x will be equal to 6 divided by 2 is 3. So you wanted to divide both sides by 2. So that's the value of x. Let's do the problem here. Again, one point outside of the circle, and we have two tangent lines. These two lines are equal to each other. 5y minus 28 is equal to 3y. So I can subtract 5y from both sides. On the left side, I have negative 28. On the right side, I have negative 2y. Now, divide both sides by negative 2. They cancel. And y is equal to 14. Okay. So here we want to find the perimeter of this triangle. So as you know, in order to find the perimeter, we need to know all the sides and add them together. But only some parts of the sides of the triangle are given. But also, I know that here I have at point J, I have two tangent lines going from here to this point and this point. So I know that these two are equal to each other because they're tangent lines coming from one point. So if this is 12, this is also 12. Now there is another tangent line coming from L to this point, and another one from L to this point. So these two are also equal to each other. So if this is 6, this one is also 6. Now here from K, we have one tangent line going here and one to this point. These two are also equal to each other. That means if this is 9, this is also 9. So now I have the length of each side. This one will be 12 plus 6, that's 18. This one is 12 plus 9, that's 21. And here is 6 plus 9, that's 15. So the perimeter will be 18 plus 15 plus 21. Now, just add those values, and they're going to be equal to 54. Okay, next problem. We have this segment AB equal to 8. AE, that's this whole line, is equal to 19. And CE is equal to 17. Now it's asking us to find line BC, this part. This is what we want to find. Okay, so again, we see some tangent lines from one point going to the circle. So here, a tangent line going from A to B, and from the same point goes here as well. So if this is 8, this is also 8. So the rest of the line will be 19 minus 8, which is 11. Now again, one tangent line goes from E to F, and another one goes from E to D. So these two are also equal to each other. So if this is 11, this is also 11. Now the rest of the line will be 17 minus 11. This part will be the big one minus this one. That's going to be 6. Now you see that there is a tangent line from C to D, and there's another one from C to B. So they are also equal to each other. So this is equal to 6. So BC is equal to 6. Okay, let's go to the next part. Okay, the next theorem is about intersecting chord theorem. You all remember what is a chord. If you have a triangle, and if you draw one line that starts from one side of the circumference of the circle and ends on the other side, so the endpoints are basically on the circumference, that's called a chord. Now, here we're talking about two chords that are crossing each other at one point. And as you see, as they cross, they're going to divide their line, the other lines, into two parts. So this line is divided into C and D, the other one is A and B. So the theorem says if two chords intersect in a circle, then the product or multiply of the lengths of the chords are equal. So what does that mean? That means these two parts, which is A and B, I'm going to write that here, A times B is equal to C times D. C times D. That's it. And it's easier if you think of that as a cross multiply. So you see this shape already looks like a cross multiply almost. Like this times this one is equal to this times this one. So think of it as a cross multiple, and it already looks like a multiple sign. You write A times B equal to C times D. So we're using the same theorem to work on this problem. So I see that there are two chords here. One is this one, 7 and 10. It has been divided into two pieces, 7 and 10. The other one is this. The parts are X and 14. I'm going to use that idea that we just did. So I'm going to write 7 times 10, similar to cross multiple, is equal to X times 14. Now, in order to solve, you're going to divide both sides by 14. These two cancel, and X will be 70 divided by 14, which is 5. Let's do this one. Again, two chords are crossing each other inside the circle. So you can do the cross multiple. 8 times 3 is 4 times X. Okay, so I'm going to write 8 times 3 is equal to 4 times X. Now, I'm going to divide both sides by 4. So X will be 24. X will be 24 divided by 4, which is equal to 6. Okay, now let's work on the next theorem that we have here. So this time we're talking about secant lines. We have learned about secant lines. If you have a circle, a secant line is similar to chord, but it's passing the circle. Like it's not going to end on the circumference. It's going to pass. So these are two secants because they're passing. Anyway, if two secants intersect in the exterior of the circle, so you see we have two secant lines, they're meeting each other at this point outside of the circle, then the product of the measure of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. It looks a little bit confusing, but the whole thing basically is simplified here. Outside times whole is equal to outside times whole. So let's see what does that mean. So I'm going to look at the first secant line. The part which is outside of the circle is this B. So this is outside of the circle. And then what is the whole? The whole is this part, this whole line, which is A plus B. And now look at the bottom one. The part which is outside is D, because that's outside of the circle. And the whole is C plus D. You're adding these two pieces to get the whole, C plus D. So the whole formula is going to be this product of these. That means you're going to write B, that's the outside, times the whole, that's A plus B. And then D, which is outside, times the whole, which is C plus D. So that's the formula that you can use for this kind of problem. So here I have one example, two secant lines. They're coming from one point. They're basically crossing each other at one point. I'm going to use the same idea. Outside times whole equal to outside times whole. Okay, so look at the one on the top. What is the outside part? It's 8. So I'm going to write 8. What is the whole? Is 8 plus x. Notice we're adding them. So that's 8 plus x. Now look at the other one. The outside part, the part which is outside of the circle, is 7. And what is the whole? That's 9 plus 7. Okay, now we're going to solve them. You can distribute the 8. 8 times 8, 64. 8 times x is 8x. And then 9 plus 7 is 16. And 16 times 7 is 112. So 9 plus 7 is 16. And 7 times 16 is 112. Now subtract 64 from both sides. It's going to be 8x equal to 112 minus 64 is 48. Now divide both sides by 8. So x will be 6. Okay. Now the last theorem that we're going to learn is the tangent secant segment. So in this case, we have one tangent line. As you see, this is the tangent line because it's touching the circle at one point and it stops there. The other one is the secant line. So this is tangent. And this one is secant. So when you have one tangent and one segment, secant segment, sorry. Okay, what do we do here? If a tangent and the secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant segment and its external secant segment. This also might look a little bit hard to understand, but again, to simplify that, we're going to use the same idea here, outside whole, outside whole. Here's the formula, outside times whole, outside times whole. So we're going to use the same thing. Now let's see how does it look like when I apply it here on this shape that you see. Okay, outside is E. What is the whole line? It's A plus E. So A plus E. And then I'm going to look at the other line, which is the tangent line. Outside, the part which is outside of the circle is C. The whole line is also C. So the outside and the whole line are the same. So that's why I have C times C. So E times A plus E is equal to C squared. So that's what we're basically doing here. Okay, so let's practice. Again, I'm going to use the same formula, outside whole, outside whole. I'm going to write that here. So the outside part here is 5. The whole is 5 plus 15. And then the second part, the tangent line, the outside is x. The whole line is also x. So we're going to solve this. 5 plus 15 is 20 times 5 equal to x squared. 20 times 5 is 100. that's equal to x squared, and x will be square root of 100, which is 10. Okay, let's work on this problem now. We have a tangent line and we have a secant line. So you're going to use the same formula, outside hole, outside hole. I'm going to write that here. Now, what is the outside part of the secant line? That's 7. What is the hole? It's 7 plus y. These two added together, these two pieces. I'm going to write 7 plus y. And then the other line, what is the outside? It's 10. What is the hole? That's again 10. Okay, so I'm going to distribute. 7 times 7 is 49, plus 7 times y is 7y. So you multiply 7 by both of these numbers. So this is 7y, and 10 times 10 is 100. Now subtract 49 from both sides, and then 7y is equal to 51. And then divide by 7. Divide both sides by 7. They cancel. And y is equal to 51 divided by 7. That's your answer. Okay, so this was today's lesson. I hope it was easy for y'all and helpful. Have a great day. Bye.